Okay, we're going to do a quick review of functions today, and just to review the definition, if it's going to be a function, every input has exactly one output. So we'll do a little compare contrast, function, not a function. The reason that this one on the right is not a function, because if I input a 1, I could get a 2 or a 3 for an answer. So that would be having two outputs for the input of 1. This having these double 2's here is legal, because if I input a 7, I could get a 2 out. I could input a 2 and get a 2 out. It's the fact that I have one output for the input. It's okay to have duplicate outputs. So that's the table version. The graph version, you probably remember the pencil test. When you leave Dover Yoda, there will be not a soul on earth that knows what the pencil test is. So probably call it the vertical line test. A vertical line is only allowed to cross a function once, and since this crosses 3 times and 3 times, you can't have the vertical line cross the function more than once, which you guys, I guess, called the pencil test. And again, going back with the theme that every input has exactly one output. If I have the square over here, that means if I had an output of like a 2, the input could have been a plus or a minus 2. I'm sorry, if the output were a 4, the input could have been a plus or minus 2 to wind up giving me that. So this one winds up having 2 outputs for the input. Something that's going to be new to you is something called mapping notation. It's just a way to represent the kind of that input-output relationship. So if I input a 1, my output is a 1. So the 1 for the x would map onto the 1 for the y. If my input is a 3, my output's a 2. So the 3 would map onto the 2. And if my input's a 7, 7 also maps onto 2. One of the things that usually goes along with functions is domain and range. You have to know what numbers you're putting in and what numbers you're putting out, or outputting. So for this function here, we're talking about the possible x values and the possible y values. So the fact that my x values are these, if I'm using a list for my function, then my domain is going to be a list. And so same thing with the range. So the possible outputs here, since my function in this little example is a list, then my domain and range will be a list. If your function is going to be written as an equation, you're going to have to do a little analysis on that equation. So first of all, when you have square roots, you can't square root a negative. So on the top of this fraction, you can't square root a negative, so x would have to be greater than or equal to 0. Similarly, you can't divide by 0, so the stuff that's in the bottom of the fraction can't be 0. So we're going to actually kind of treat this like it is 0, because then it's going to make a little bit more sense. But remember, I just kind of changed that, so we're going to have to go back and kind of fix that in a bit. We could factor this or use the zero product property in order to solve it. That's kind of why I wanted to put it equal to 0. So basically, I can take this problem. And remember that because this is a leading coefficient of 1, that's the last poster. I'm sorry, not the last poster. It's the one straight above us, which is diamond only. You could just get by with diamond only on that, but however you figure it, it's going to wind up being x plus 2 times x plus 3 equals 0. And so if I set each of those equal to 0, right, because if we're going to multiply and get 0 for an answer, one of the answers has to be 0. So in this case, x is -2 and x is -3. But remember that I switched that, right, because this was x can't be 0. So x can't be -2 and x can't be -3. So now we have to figure out how to kind of combine these two answers. You know, and if I think about it on a number line, that, you know, x is greater than or equal to 0 would be, you know, closed circle and shading to the right. And then I can't have a -2 and I can't have a -3. Well, because those are to the left of this shaded area, then really the fact that I said x is greater than or equal to 0 kind of covers the domain part. Okay, so basically what I would say for the domain is that I would go square bracket 0 to infinity with a parenthesis like that. You might have also written that as 0 is less than or equal to x, which is less than infinity. Maybe that makes more sense to you. You know, I just looked at the instructions, and they didn't actually ask you to find the range. All right, so some of the problems are going to ask you to do combining of functions. And in this case, it just said adding. So in this case, I'm just going to take f of x, which was square root of x plus 1, and add that to g of x, which is 2 over x. And I don't know if there's any real simplifying to do for this one, but this one's just adding. Now, they also asked you to find the domain restrictions on this. So this is only going to work for a couple of situations. First of all, x plus 1 has to be greater than or equal to 0 because you can't square root a negative. So if I solve that, it's going to be -1, and x has to be greater than or equal to -1. And in this case, because we're dividing, we can't divide by 0, so x can't be 0. So now I have to figure out how to combine these two things into one. So, you know, if I think about it on a number line and say, all right, here's 0, that can't happen. So it's kind of an open circle at 0. It's going to be a closed circle at -1, but it's greater than or equal to. So writing this in interval notation, I would say the domain would be equal to -1 over to 0, but it can't include 0, so because it's an open circle. And then I go union, and then from 0 all the way over to infinity, like that. So that would be the domain restriction for this particular question. So this next example just asks you to divide them. There's kind of an additional domain restriction, and maybe it's not going to matter because of the functions I chose. But there's an additional domain restriction on this one because this whole piece can't be 0. Which, oddly enough, I guess I picked something that couldn't be 0. Right? Because, you know, how do you divide and get 0 for an answer? You can't, right? So that can't be 0, but because this is a 2 and not a 0, you can't divide by anything and get 0 for an answer. Hey, I picked one that you can't hardly screw up. So there is no domain restriction because that bottom part can't be 0, just because of the example that it was. But you still have to have this limitation here where x plus 1 has to be greater than or equal to 0. So if I subtract 1 from both sides, x has to be greater than or equal to -1. So I guess you could write it like this, or you could write it with a -1 and a square bracket and a positive infinity if you wanted to, because I don't think we can mess that up. However, I don't think that that this equation is as simple as it probably could be. Let me pop that out of there, and let's simplify that. So I would probably multiply this by x, you know, over 1 over, you know, x over 1, so that the x's are going to wind up canceling here. So I'm going to have the square root of x plus 1 times x all over 2. I don't know where the most simple version of that problem is. I mean, maybe you could write it as a half x times the square root of x plus 1. I don't know where necessarily to leave that one. You And I don't know how many hairs I'm going to split on that either. Uh, but you do need to simplify as much as possible. And I think this is probably as simple of an answer as we have. Okay, so the last example is going to be a little bit of plugging numbers in. So to find f of x plus h, I have to put an x plus h in for those two x's. So that problem is going to turn into x plus, oh, maybe if I color code that a little bit better, it's going to turn into x plus h quantity squared plus 2 times x plus h. I didn't color code that right. Still didn't color code it right. Plus 3 minus, and don't forget this parenthesis, that's going to be pretty key for you right here. So here, I'm just going to write in my x plus, or my f of x. So that's going to be x squared plus 2x plus 3, and all over h. Oops. Don't forget when you square this out, this is going to be x plus h times x plus h, which is going to be x squared plus 2xh plus h squared plus, I have to distribute that in, 2x plus 2h plus 3. Don't forget to distribute your negative, so that's going to be minus x squared minus 2x minus 3 all over h, and a bunch of stuff is going to combine. So, for example, the x squareds are going to cancel. Hey, Jenna, do you recognize that formula? Yes, the formula for a first derivative. Excellent, excellent. You should have known that when we took pre-calc. Okay. Okay, let's see. I think the 3's are going to cancel. And yeah, so you're going to wind up with 2xh plus h squared plus 2h all over h. And then I think your h's are going to cancel. So that's going to be 2x plus h plus 2. So you also already heard that this is kind of the formula for something that's pretty huge in calculus. When I get back, I can tell you the story on how that was one of my college entrance exams. I'll try to remember to put in my sub notes that, because I burnt through this pretty quick, to pause or rewind or whatever you need to replay, or if you need time to recopy something down. So good luck. Have fun. We're going to have a quiz coming up here on section 1.1 to 1.4. So you already picked up on that. So here's your homework. Remember, I'm trying to shorten these assignments up a little bit so that if, even if you don't just want to do the first and last odd, if you got a section that didn't make sense to you and you need to take a couple more paths through the woods, you certainly can. And it says here at least one from each section. So again, if you struggle on something, you can do extra. Okay, I remember talking about finding the domain and range from an equation and finding the domain and range from a table. I forgot to talk about finding domain and range from a graph, and that reminded me my fourth block because they like singing so much. The domain on the graph goes left and right, left and right, left and right. The domain on the graph goes left and right, all through the... I didn't know what to put at the end. The range on the graph goes down and up, down and up, down and up. The range on the graph goes down and up all through the graph.